All right, everybody, in today's video, I'm going to talk about loading data into different kinds of databases using Python. So why would we need to do this? Well, there's several advantages. Of course, automation, anything that could be automated should be automated, right? If you automate a task, it's going to be done very quickly without mistakes. A person doesn't need to get involved, right? So it won't be time consuming or tedious. You can just automate the task and it'll probably be done in a matter of minutes or seconds rather than having a person do it. And it could take, who knows how long, several minutes, maybe 15, 20 minutes, maybe longer. And there could be mistakes, right? Humans are prone to making mistakes. Computers are not. Very flexible. Python is versatile, flexible, very scalable. Python integrates fantastically with all kinds of databases, any kind of ANSI SQL, any kind of pyodbc, pycon2. There's seamless integration, and the number of databases that Python can communicate with is probably several dozen. It's pretty huge number at this point. So data transformation is another reason, right? You can use Python to do extractions from the web, from data lake, from another database, any kind of data storage. The file could be anything from a CSV to a XML, JSON string, any kind of zip file. The data could come from an FTP folder, right? Any kind of source, and it could be manipulated, aggregated, parsed, cleaned, pivoted or unpivoted, and then loaded into a database, right? So you can do all kinds of customization, transformation. Python's very scalable. It scales up and it scales out very easily, right? So you can load anywhere from hundreds of records to millions to tens of millions, right? You can do it in chunks. So if the cache isn't large enough, or if the memory isn't large enough, you can't get everything in one go. You could do it in chunks and do the process in iterations, right? Python handles cross-platform compatibility pretty well. It works with Windows, Mac, Linux types of OSs, and of course it's open source, right? So the SQL system is 100% free. All the code is visible. You can explore and expose any kind of Python library, right? It's not hidden like you would see in Windows or any kind of Microsoft Office product. Everything is fully exposed to you, and it's 100% free too. So lots of good reasons to use Python to interact with data and then eventually load it into the database, some type of database, preserve or long-term preservation type of data storage, right? So in the case of SQL Server, you can interact with this using pyodbc. So this is the library. This is pretty key. With this, you can do any kind of select, insert, update, and delete, just like you would do in SQL, and you can do all that in Python. You would create a connection string with an ODBC driver. Okay. You have to check the driver that you have on your Windows system. So let me see if I have ODBC. If I can look for over here, ODBC. And yep, there it is. So let me go to 64-bit. That's what I'm using now. I'm not even sure why we have a 32-bit here, but anyways, let me look at this just to give you an idea of what these typically would look like, right? So you would get the driver. It has to match whatever you have on your system. You would have a connection string that points to this database, right? Here's DNS, I think. Is that it? No, user DNS, not system. Okay, and then you would add it. Let's see, add over here. Do I have my SQL Server set up? I guess I do not. Okay. So here it is. ODBC driver 17 SQL Server. Oh, whatever it is set up. So yours would have to match that. So you have a driver 17. You could have a 16, 17, 18. They might even have 19, 20 out now. But whatever your driver is that's installed, that has to match your code over here. Okay, so I have driver 17 for SQL Server. Let me hit cancel. Let me hit cancel and get out here. So yours has to match that. Whatever it is, you would just use that right here. Okay, so those have to match up. You would have your connection string. Okay, that's right here. Okay, and that's the name of the server. and then whatever kind of connection string you use. I have a backslash here, SQL Server Express, the name of the database that you're writing to, and then your credentials, right? So almost guaranteed you need credentials. If you're logging into a remote system, you'll absolutely have to have your credentials to log in. If it's local, you might be able to get away with not having credentials, but it's still good practice just to have that, right? So you have the database name, and then your credentials, and then down here, those are all commented out. So this would be the actual code right here. Test connection, trusted connection. Okay, so if the connection is trusted and it's local, you don't need credentials, right? But if it's a remote login, you will need credentials, right? So just be aware of that. Here's a CSV file. I'm going to load that, read it. That's what the R is for down here. And the quotes show you the path to the file. So R, this actually probably has to have double backslashes. I'm not sure why that has a single. On a, I think on a Unix system, you can get away with a single. Windows needs double backslashes because the backslash a long time ago was used as the escape character, right? But when you use two together, then Python knows that this is an actual directory path to file, right? So that will load the CSV or read the CSV. Okay, read it into memory and create the columns. So that is structured as a CSV file, right, with all the columns and rows. You will go ahead and create a table query, and a cursor will loop through all the records. Now, if you have a small data set, a cursor is fine. It's going to go record by record. It's going to go pretty quick. But if you have millions of records, you're not going to want to use a cursor. You're going to want to read the file into chunks, or if you have enough memory, read the entire file into probably a data frame or something like that, and then push all of that into your SQL Server database using pyodbc. So there's a lot of documentation online. You'll get everything you need. These are all the commands to do the job right here. I'll share this with you when I post a video. You'll have all the business logic and all the commands to go ahead and write to your SQL Server database. You would have to, of course, change the driver to match whatever you're using, and your SQL Server name, right? Whatever connection string, and then the database that you're writing to. And that's it, right? And then if you're appending to a table, you would need one more parameter for the table, and you can do an append, you can do an insert, you can do an upsert. An upsert is kind of a combination of an insert and an update. So if the record exists, you would update it to the current record, and if it doesn't exist, you would insert it. That's an upsert. Okay, so there's a few different ways to do that. Let's scroll down and see what the next thing is here. Okay, so here, okay, so yes, we're doing essentially the same thing. That was using a cursor to do the task. Now, if the data is too big for a cursor, or it's going to take too long, you don't want to loop over all the records. You want to do everything in one go. You can use pyodbc. This is very efficient. I've used this in the past to load hundreds of files into SQL Server database. It's pretty fast, pretty efficient. And you would have the name of the server, right? The table goes right here, my test, I'm calling it. And then, of course, your ODBC connection string logic over here, right? And that is pretty much it. And then df to SQL is a nice little way to get the data frame into SQL. You list the table that's going to, the connection is the engine. The engine is the whole connection string. You can see it right here, create engine with this connection string. And if exists, append. If it doesn't exist, it's going to insert it. So this bit of logic says, look for the table. If the table exists, append to the table. If it doesn't exist, create a brand new table. So that is pretty useful, right? If you're doing updates, if you're doing upserts, if you're doing inserts, whatever the case may be, that can handle all of the scenarios pretty effortlessly, I think. Now, if you're using a MongoDB, this is more of a non-SQL type of database. I don't use this a lot. I've used it a little bit in the past. I had MongoDB set up. So I loaded a JSON file into a MongoDB. That is probably not going to happen in a structured SQL Server database. Although I think nowadays, I think they do have commands for reading JSON strings into a structured table. So I think you can use SQL for that and probably use Python. But typically that would go into a NoSQL database like a MongoDB. So you'd have your Mongo localhost and then the name of the database. I think this is the default. I think that's default for everybody. So if you set up your default Mongo, your setup will be exactly like this. You would go ahead and open the JSON file. This is coming from my desktop. I don't even think the file's there, but it would actually be like this. Double backslash, right? And then we can go ahead and load that file. that JSON file into the MongoDB and then go look at it or do whatever you have to do. Okay, so here's another JSON string. Mongo, again, 27017. I think that's just a standard default naming convention for Mongo. I haven't used it too much. I've used it a little bit in the past, but this is what the code would look like. And your setup might be slightly different, right? This is just generally how you would do this type of task. I can't say it's going to be exactly the same. Your setup probably will be slightly different from mine, but this certainly is the concept, and this code is probably 95% of what you need, maybe more of what you need to get this up and running pretty quick and pretty effortlessly. Okay, and then you would close the client. Once you open the client, you run the task and then you close it. So JSON is JavaScript object notation. XML is extensible markup language, right? Both formats are pretty popular for saving and storing data, and a bunch of different data types. It's very machine readable. Not so easy for a person to read JSON strings, but if they are exploded, or I think it's called exploded, then you can see the structure. There could be many layers or many levels of a JSON string, right? So you might have to explode it multiple times, but anyways, the machine can read it pretty easily, and for a human to read it, you might have to explode it. XML is pretty machine readable for a human or for a computer, so those are pretty popular ways of storing data. And of course, these will go into a NoSQL database. And if you had more column and row type of data, like CSV files or Excel files or text files that are arranged as columns and rows, that could go into a SQL Server database pretty easily, right? And again, benefits to working with JSON and XML files is overall storage. They tend to be pretty well compressed, pretty efficient, easy to parse. The schema is supported by any number of different databases. Python has full capabilities to interpret JSON and XML data, and these are just popular tools that are used all over the web today, and all kinds of different databases or data sources, right? So again, if this is going into Mongo, here's another example. The localhost default would be 27017, and again, this file is saved on my desktop. There's probably two. It's going to be two. Permission guaranteed. It's going to be 2 backslashes. And we would have that on the desktop most likely. So let me just fix this up. This is just cosmetic. I'm not even going to run this today, so it doesn't really matter. And then desktop. 2 backslashes. Nope. Computer is very laggy. Okay, so we have that done, and then this is looking for, so it has to parse the XML file. It is looking for a certain hierarchy in the XML file, right? So if child tag equals change, this is a specific file I was working with earlier today. If we have that, then we have to parse it. This is a specific hierarchy, right? And we would go ahead and import that XML and push it into the database, and then close the client, right? The client is opened to do the task and then closed after we're done with it, so it doesn't just sit idle and use resources in the background and suck up some of your memory and make things run slower. Maybe that's why my machine's running kind of slow today. Okay, so we have another example of loading an XML file into a pymongo DB, so slightly different database. I'm sorry, slightly different driver to access the database. It's exactly the same database. Sorry, I misspoke there. So same thing, same concept. We've seen a couple different versions of this. Okay, close the client when you're done. This is an XML file that I can download from the web, and again, load that into my MongoDB database, right? XML or JSON can easily go into a NoSQL database. There's several. I think Mongo is open source, totally free, and pretty scalable. I think that's a pretty popular option. There's a few alternatives if you don't like Mongo. There's a couple other popular NoSQL databases out there that you can go to. Let me just take a quick look at this. I don't think we need this thing. Just want to see what it looks like. Does it even work? Try one more time. If it doesn't work, then we're out of here. Oh, you know what? I think it's just downloading it straight to my download folder. Okay, that doesn't matter. Just wanted to take a quick look at that thing. Okay, and pitch black. That's nice. That's always nice. Okay, so that's it. I think that's pretty much it. I promised you a pretty short video this time. Just wanted to take you through the nuts and bolts of storing data into a couple different databases, persistent SQL Server, column, row, structured database. SQL Server has been around for probably like 25 years now, pretty established. You see these things everywhere, all over the business world. And MongoDB is a pretty popular alternative as a NoSQL database. I've used that a little bit in the past, used SQL Server much more than Mongo, but they're both nice. And of course, Python will interact with both of them seamlessly, quickly, effortlessly, and this stuff is pretty easy to get set up and to get going with. So that's it. So hopefully I was able to drop some knowledge here. I've got a couple more notes. I'm going to save this file and post it when I post the video. Hopefully you guys were able to learn a couple new tricks today. That's my goal, to keep these videos tight, crisp, to the point, and very generic. So you can take this and apply it to your own specific situation and solve your own specific needs. Right? I'm trying to keep all these videos to the point so I can illustrate the topic of whatever I'm discussing, but also make it generic enough for you to just take this, pick up the code, copy and paste it, and hopefully you have maybe 90 to 95% of what you need, and you can just run it and get what you need, but based on your specific data set. Obviously not mine, but your specific data. But the concept should be probably 90 to 95% exactly the same. Okay, so that's pretty much it. Thanks for your time today. As always, have a wonderful day. Thanks, guys. Goodbye.